All right, welcome back to the course. We are now in section 5. We're talking about using plugins and services. In this particular video, we're going to talk about using third-party plugins. So what do we mean by that? On Android, you have a few different plugin types, actually. You have AAR files and jar files, and those are kind of, you could think of them as zip files containing some native Android code. And you use these when you want to expand the functionality of your game or app to use native Android functionality that Unity doesn't provide. So for example, if you want access to the user's gallery, AAR and jar files, and native C++ files. Native C++ tend to be DLLs or .so files or something like that. If you run into these files, you'll kind of know what they are. But if you don't worry too much about it. I'm just going to talk about how you implement these. Then we have iOS plugin type. And for iOS plugin types, you have static libraries, which are .a files. And then you can also have source files, .m, .h, .mm. These are files that you use when you're doing Android development. These are Objective-C files, header files, and Objective-C++ files. So let's go ahead and take a look at what this looks like inside of Unity. So let's go to Unity and take it from there. Okay, so we're here inside of Unity. I've brought in a couple of different plugins already. One thing to note is that you no longer have to place these inside of the plugins folder as you did in prior versions of Unity. That said, it's still not bad practice to do so. Keep in mind though that this folder will get copied to the appropriate platform when you build. So when you build an Xcode project for iOS, this file gets copied over. Anything inside plugins will get copied over to the Xcode project. That doesn't necessarily mean it'll get included in the build or anything like that, but you will see it pop up. So just be wary of that in case you have any stray files sitting around. Now, what I've got here are 3 different files. So I've got a file called MyAppController, Screenshot Creator, and then another one called Screenshot Creator. Now the difference between these files is that one is an M file and one is an H file. Let's open up MyAppController so you can see what's going on. So we've opened this here in Visual Studio Code, and we can see that it's a .mm file, and you can see a bunch of Objective-C code in here, essentially trying to define some functionality here, including some sort of template. By the way, I grabbed this plugin from the Unity Bitbucket page. This is a native sort of texture plugin. You should check it out. It's pretty cool. And then the difference here is that the Screenshot Controller Creator is a MM file, which includes the H file, and this one down here is the H file, which is the header file, and it declares all the functionality here, and then it's defined in this file. And so all of the logic actually happens in here. Okay, one thing that you will notice about these is that when they're declared, they need to also be exported. So you'll see that this extern C void capture screenshot call, this gets exported out, and this is what can be called from Unity. Now to call the actual plugin in Unity, you actually just have to know what you need to pass to it and the name of the method. So let's go back to Unity. And I've got this test screenshot file here, also included with a plugin, that will sort of demonstrate how you use the code rather than just dropping in your project. So let's open this up and we'll take a look in just a moment when it loads. Okay, so the file here is now mostly loaded. You'll notice a few things about it. This is a plain old C# file. It's test-screenshot.cs. So you're going to be familiar with this code. One thing that you may not necessarily be familiar with is this mono pinvoke callback. So this mono pinvoke callback allows you to basically marshal callbacks back and forth between the native code and the Unity code. And so we are declaring this here. This is something that will be available to the native code. And then what we do here is to actually use the native code that we have. If we go back just for a quick moment, it's called capture screenshot is the name of the method, okay? So back in our C# Unity code, we see that we've defined out a few things. So this if define, #if is saying that if we're on the Unity platform and not in the editor, this code will compile. Otherwise, it won't compile. So anything after this is exempt from this condition. The reason we do this is because when you're working with other platforms, this code won't compile because it's iOS specific. So it just won't work on Android or standalone or even in the editor. We do this just to keep our code nice and clean and not include anything that's going to cause issues later. Okay, so one thing you'll notice, we use DLL import. It's not a DLL, but this is just sort of the attribute we use. And we pass in __ internal. And this allows us to expose the calls from the native code to Unity. And you'll see that we have a private static external call to the capture screenshot method, which takes a delegate called completed. And if you remember, we declared this callback here as being accessible to the native code. So that allows us to pass in this callback, screenshot completed callback, right here, to the native code. As completed is what the name of it is. And then we pass a string, which is the file name. And then in our OnGUI code, we just simply call screenshot, pass in the callback, and then test file, which should be in your project when you run this. Of course, we're not going to really worry too much about the specifics of what this code does, so much as we are concerned with how to use the code. So let's jump back to this Objective-C code one more time. And you'll see that it's taking a screenshot complete callback. A method pointer, rather, is what you would want to call this. And the only way that this can have access to it is if you made that attribute on the Unity side. And then it's, of course, using the file name here. And then it's calling some other code. And so that's how you use native plugins. This is probably the best way to do it. There is another way which allows you to send messages from Objective-C, so from iOS, using the send message. That one is not really great. It requires that you have a game object that's sitting there waiting to listen to these things, and it sends message using Unity send message, which is just not very efficient. So I will not cover that here. This is the preferred way, and I would recommend that you go this way. Okay, so back into Unity. Our plugins, as you notice when you click them, because you don't have to have them in the plugins folder anymore, you may sometimes need to specify that this is a plugin for only a specific platform. So here you see include the platform, so you can put it for editor, standalone, or Android. Now, of course, these are iOS plugins, and I'm on a Windows machine, so I won't be able to do that here, but you would have the iOS checkbox here. We'll see that in the next section. We actually build our iOS app. I'll switch over to a Mac machine and we'll do it there. But for now, just note that you would have to select the right platform here. So for Android, on the Android side, I've created this sample debug code here that essentially allows you to get some debug information from your app. Now, process is identical to how you use it. I just wanted to make a note that this is an AAR file. And again, it's by default selected as an Android plugin. You don't really have to do much else with it. It's set. But this is an AAR file. So let me show you this in Explorer. And you'll notice that this is basically a zip file. So let's open it up with, I have 7 zips. I'm going to open the archive. And when I open that up, you'll notice that this is a zip file that contains a whole bunch of stuff in it. This resources folder, for example, the values, string file. If we can go back up, you'll see that there's an Android manifest included, along with some assets and whatnot. And then, of course, classes jar file. Jar file is another zip file that contains some information for Java classes, Java programs. So that's all it really is. So if you ever have any issues with debugging, seeing what's inside of here, you can just open it up with any zip utility. On Mac, of course, it's easier. You just double click it and open it up, or open package contents. But for Windows, just unzip it and you can see what's inside. All right, so that is how you implement and you bring in plugins for native platforms into Unity.